Hello, I'm Maker Melissa. I am sponsored by Adafruit to work on CircuitPython and other projects. And today I'm going to be doing my very first live stream. And for this one, I'm going to be building a little robotics project. Let me go ahead and share my other camera here. And what I have is I'm building one of these little cars. Oops. These little cars here with a CLUE, and it's the Ringbot car. So what I want to start by doing is assembling the Ringbot car, just to show you how that goes together. And I'm going to go over here and make sure I'm in the chat in case anybody has any questions. Okay, so let's go ahead and start by seeing what is in this. So it has just a bunch of little packages, including some servos, the wheels, the body, and it has a couple boards here. It also includes a screwdriver and a little manual. And I'm going to go ahead and set this stuff aside here. And I'm going to be using, actually, I'm going to use this screwdriver here, just because I can build it a little faster since it has a bigger handle. So the first thing to do is to start out with taking stuff out of the packages. Now with these bags, we will need just the tiny screws that attach into the servo itself. We won't need the servo horns or the mounting screws. Ah, there it is. And then we're going to go ahead and open this one. And it includes a bunch of screws already in here, which is why we don't need those other screws. So we're going to start out by building the servos into these. And what we want to make sure is that the front of the servo is towards the front of the car here. And we're going to go ahead and mount screws into the underside here. Oh, that's the wrong screw. Okay, and then we're going to do the same thing on the other side, but we're going to kind of mirror it. And then on this, you look at the wheels, they kind of go in on one side and they're flat on the other. We want to put the flat side towards the servo itself. And then we'll use one of these little screws that came with the servo. And we're going to do the same thing on this side. Then we're going to take one side of this. Oh, actually, we're going to go ahead and install this little wheel with these little rivets. And I found it easiest just to start by inserting it in here and then sliding this in sideways. And just move that mouse out of the way. And then these are a little tricky because you don't want to push down on them until they're in place. And then when you just push on them, it kind of pop through and it holds it in place. Let's go ahead and install all the pieces along here. So this piece goes here. This flat piece goes here. And these pieces are all symmetrical, so it doesn't really matter which way that you insert it. And I'm going to go ahead and open this package up here. And I'm going to go ahead and attach this. And the switch should be towards the bottom of the car here. So it goes like that. And I'm going to go ahead and make sure the wires are just kind of going through here for the moment. This is probably the trickiest part of the build. Okay, make sure every one of these tabs is in. There we go. And then the next thing we use is this little thing as a screw in the end. And we just go ahead and insert it through here. And insert this side here. And that's it. So the car is mostly built now. I'll go ahead and move this. And we're going to open up this side. Now I've already gone ahead and programmed this clue, but now is actually a really good time if you're building this yourself to do it because the reset button will be up against this board, but even if it is mounted, you can still use like a little flathead screwdriver like this and kind of get it in there and push the button a couple times. So I found it easiest to go ahead and start with the screws on the ends here. And let's see. Go one here. One here. I'll take a look at some of these. Yes, in case anyone missed it, I am actually putting together a little robotic car like this, and then I'll give you a demonstration in just a second. And I will go over the code that is on here. Okay, so it just takes 5 screws there. Then you want to make sure the wires are kind of routed behind this bar. And we can go ahead and install some batteries in this. I think the little switch is on by default, so I'm going to just turn it off for the moment. Oh, that's interesting. This is missing a spring, it looks like. So I guess I won't be able to demonstrate this particular car. Well, I'll just go ahead and show you for assembling it. So you want to install this wire, which went underneath there, here, and you want to match the 0, V, and G. You want to match the black to the ground. And then on this one, you want to plug in the 2 servos mounted here. And if it's backwards in the code, you can either switch it in the code easily, or you can just swap out the plugs, because what'll happen is it'll actually go the wrong direction when you go to run it. But you go ahead and take this. You can take this little clear rubber band and bound up these wires. Let's see if I had the spring fall out in here or something. No, it's just missing altogether. That's odd. Well, oh, this one came with 2 rubber bands too. Well, I'll show you with one of these cars here, because I know that's all working. And so I'm going to pull this little thing off. So when you turn it on, it goes ahead and initializes. I have it running CircuitPython 8 right now. And then I'm going to go ahead and just show you this iPad here, because I have it running Adafruit Bluefruit Connect. And I'm going to go ahead and connect to it. Oh, you can't really see very well with the glare. Let's see if I can tilt it a little. Okay, so we're going to go to controller, and we're going to go to the control pad. And if I press up, it starts going forward. I have one set as stop, and you can go backwards. And you can also turn on the spot, or the other direction. Or if you're going forward, you can kind of turn as you're going and then stop it. And then I have 4 set for turning on the little lights here if you want to show little headlights. And then I just have 2 and 3 changing the underglow color. You can also go to the color picker here, and if you want to go to a custom one, you can send it and it'll set it to something that looks similar to this, but I think it's off a little bit. Or we can go more white if we wanted to, or red, whatever you want to do. And then if you go back to the control pad, you can drive it, and you'll notice it changes colors as it's driving, but it'll go back to the custom color that you set. And so I'm going to go ahead and go over the code next here. So I'm going to plug this in. And let me go ahead and share my editor. Let's see, was it? Oh, there, that's what I'm looking for. So here is the editor. Let me go ahead and shrink this window a little bit so you can see it better. So the code.py is just really, it initializes it. It goes ahead and it imports board and NeoPixel and a custom class that I wrote called Robot here. And let me go ahead and change this around a little bit here. Ah, perfect. And then I have it defining the different connections for the Ringbot Buggy or Ringbit Buggy here, or Ringbit car, depending on what you want to call it. And that way you can go ahead and change the connections really easily in the software if you want to. I have it initializing the NeoPixel class. It only has 2 NeoPixels underneath it. Oh, you can't see it because I turned off the camera. It has just 2 NeoPixels here. So I'm only initializing it with 2 of them. And then it initializes the robot with just the hardware specific to the little car. And in the while loop, it just waits for a connection. And once it's connected, it'll just kind of check the packets and process them. So we'll go over to the robot class. And I'm going to go ahead and take a look at Discord here. Let's see. DJ Devon3 asks, is the robot class part of an available library? And I'm going to, with this one, it's actually a custom one that I wrote. I'm planning on writing a guide here, and I can go ahead and attach it there. But at the moment, I have it available on my GitHub account, and I can share that soon. But I don't think it has the very latest changes, so I want to push that up before I post a link to that. It'll eventually be part of the Adafruit Learn Guide repo. So let's go over the robot class here. So it just grabs in a bunch of different modules, including the PWMIO here. It does a bunch of the display IO related classes for being able to display like text on here, or some of the vector graphics that I added. As you notice, the little arrows as it was turning, I just used vector IO for that. So there's actually no separate images on this class here. but that would be a fairly easy change to make. It includes a lot of the different definitions from the Bluefruit Connect service here for the different types of packets. And it looks like I have some duplicate code in here that I don't know why it's in there, but we can go ahead and remove some of this. Okay, so that was a little extraneous. And of course, I have a little label here for just being able to show the wait for connection. So then I have some definitions here for the throttle directions and speeds. And that way we can set it to go different color or different amounts, up to 1.0 being full speed and -1 being full reverse speed. And then I just have a few of the different colors for convenience of programming this. And then the initialization, we just are basically initializing the left and right motor, which has a little class here. And the reason I have the class method on these ones is because it allows me to make this method part of the class without actually making use of the word self keyword in here. And because these ones actually could sit as functions outside of the class itself, but I wanted to include them. So all this does is it creates a PWMIO class and then passes that over to the Adafruit motor continuous servo one, because that's what these are. And I just have some max and min pulses. I could probably make those properties so they're easier to adjust, like up here. And then we go ahead and initialize the display, which it just does anything display related for like setting the background color. I have it creating that's just creating the rectangle for a background instead of using like a bitmap. And then I go ahead and I add it to the display group. And then the init BLE stuff is just setting up like the BLE radio, the UART service, and just all the initialization stuff you need to do in order to use it. And then I have it going through and setting up a few variables, including the little headlights one, which is what I decided to call it, setting the initial color to purple, and then making sure in case it's running for whatever reason, it'll stop it. That's why I have it doing the set speed. And let's go ahead and jump down here. Oh, this make palette class was just a little convenient function for being able to create a one color palette and just returning it, because I use that in a number of places. So the wait for connection method, what that'll do is it starts by setting the status LED, which is just the little NeoPixel on the back of the clue here. And it sets that to blue. Then it starts advertising so that the Adafruit Connect program will be able to see the clue. And then it just kind of waits until it is connected. And once it's connected, it'll stop showing that it's available. It'll set it to green. And again, I'm setting the throttle to stop. The reason I'm doing that is it will actually update the icon on here as well. I have a little convenience function for is connected. That's back in code. It can check if it's connected here. And then I have a couple functions called set underglow and get underglow. And what that will do is this will set the color of the NeoPixels down here, but I'm also making use of the NeoPixel class to store the color value. So I'm just grabbing it from there for getting the current color. I wanted to use as few variables as possible. And then the status LED is just the one in the back of here. The toggle headlights will just kind of go turn on and off this, and it just, again, makes use of the existing value variable in the digital IO class, so that we're not having to store it in addition to that. I have a set left throttle and a right throttle, and since they're mounted 180 degrees to each other, I have to actually multiply the speed by -1 so that they're kind of both turning the wheel in the forward or the reverse direction. Now, the rotate right, what that will do is it will, well, first of all, let me start with the release color. What that means is it'll set the color of these when you release the button. So like when you're turning left or right. And then, so then while you're holding it, it'll set the underglow to yellow. And true just means, I actually don't remember what that means. We'll get to that. Or no, it's up here. So, oh, save release color. That just means it'll kind of set that as its new color. Or oh, okay. No, it'll get the current underglow and it'll save it. That's what it'll do. And then we're using these if here, let me expand this a little bit. We're using these style here just to make it so instead of it being 4 lines, it's just 1 line. And what this does is it'll run this function if the current direction is stopped, otherwise it'll turn it right. And we do something similar for the speed, and then we set the left and right throttle. This allows me to use the same function in order to either or spin around in a, here, let me go ahead and demonstrate here. Let me share the camera again. Oh, let's just do this. Okay. Okay, I'm going to reconnect with the program. Okay, so what this function will actually allow me to do is it'll allow me to use the same function both for spinning it while it's stopped and also doing a kind of a half turn while it's going. Let me go back to this. And then I just have one for the rotate left and rotate right. I probably could have combined these at some point, but it was easier just to have it separate. So then I have the set throttle. What this does is it'll, depending on what speed that you're giving it, if it's forward, it'll set the little icon to a forward icon, or a reverse icon if you're going backwards, or stopped if you're stopped. And then I have a set speed as a separate function so that I can call it without changing the icon on there. And then just sets everything to whatever speed you want. And then the stop function here will basically call the set throttle with a stop, and it'll actually show the red underglow for just about half of a second here, and then it'll go back to whatever color it was. The check for packets is again called over in the main function here, and this just sends, it just checks to see if there's something waiting, and if there is, then it'll process it, and we'll get to that a little bit later. The handle color packet will just, I'm just telling it if it's a color type packet, we're gonna just set the underglow to it. And remove shapes is just a function to the, okay, I'm sorry. Remove shapes will just kind of remove everything except for the first object in the display IO group, and that just makes it really easy just to clear whatever's on the screen. I just made some convenience functions called add center direct. So you can just give it a width and a height or an offset if you need to, or change the color. These functions are kind of like the basis for drawing these shapes here. I just did a centered polygon and a centered circle as well. And actually, I'm going to show you something kind of cool that I did. So I had it figuring out like kind of the dimensions of the shape, and it just kind of uses a min and a max function here. It uses the lambda item, and what this does is it says, give me the largest value of the first part of the point, because it's kind of a list. Well, I'll show you. It's kind of a list of coordinates, so it just tells me like the largest of this, 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 and this one here. And I do the same thing with the other ones, and then I do minimum ones as well. And it provides a nice compact way of determining where the center of the polygon is. Similar for the circle here. And then the waiting one, all it does is it just draws a label here and says waiting for connection. And then the reverse one, it clears the screen and it draws a couple polygons to make it with a arrow that appears to be kind of going backwards. I had to play with that just a little bit. Same with the forwards. And then I have right, left, and rotate counterclockwise, rotate clockwise. These ones I just basically drew a big black circle, a little yellow circle in the middle of it, and then a rectangle to kind of split it into like two half circles, or like two half donut shapes. And then I have these just adding little arrowheads to that. And then it looks like it's a rotating circle. And for the stop one, it's just a big square. It was easy. Okay, so we're now at the handle button press packet. We're actually almost done with going through the code here. And all I'm doing is I'm just telling it for whichever of the buttons I'm doing, I'm running these different functions here. So it makes it really easy to switch around what you want it to do. This one allows me to handle the button release packet, whereas this is the press packet. And this allows me to kind of steer the left and the right while it's going forward without losing the speed or the direction. And the process packet just checks for the kind of packet it is and then sends it to the appropriate function. And that is it for the code. Let me go ahead and save it with those things removed. Let's see, we're about out of time. Well, no, we have a little bit more time. Does anybody have any questions you can ask in Discord or even on YouTube, because I can see the comments for that as well. And I'd like to answer that. Let's see. So I will, I do have a couple things to say. Just add your questions if you have them. So if you wanted to expand this, there's actually a lot of different options for expanding it. First of all, this has the stemma QT port up here, and that allows for adding all sorts of different sensors, but there's also a lot built into the CLUE here. One of the things that I wanted to add was a little playing sound, but I just ran out of time for adding that because it has a little speaker built in. But it also has a microphone. It has a button if you wanted to change modes. I didn't add that at all. It has a color/distance sensor. It has 9 degrees of freedom for the motion, so it can kind of check any of the orientations that it wants, so it could react to that way. And let me bring up my list of. Oh yeah, that's pretty much it. And then you can, like I said, you can add stuff with the stemma QT port. There is kind of a built-in little port for combining with the robot, but I think what they use is that for programming the thing. It only allows for really a digital I/O and some power, and you can't use the LEDs at the same time. But you would just move the little switch over, and I'm going to go ahead and push these changes really quick to GitHub. This won't take very long. So first of all, I'll grab the changes off the robot. Paste them to replace that. And then I'm just going to go ahead and okay, now I have the latest changes, and I will post where the GitHub repository is that I have. It's just on my personal one at the moment, but it will be moved to the Adafruit one eventually. And there it is. And that includes all the changes I just made with removing some of the duplicate code. Let's see here. Taking a look at the comments, see if I missed anything. Not seeing anything I missed. Oh, thank you. So this was originally designed for the BBC microbit, and the BBC microbit V2 could work because it also has Bluetooth, but it is missing the screen. It has like 25 LEDs and a 5x5 grid, and it does not have the STEMMA port, and I'm not sure it has the color distance sensor, but it has a bunch of other things. It would be a capable board for sure, and it's able to run CircuitPython as well. But it's also really difficult to get at the moment too. So the CLUE board would be definitely my recommendation for this. And the code, of course, would need to be modified in order to use that. I think that is it, unless there's any other questions. I see somebody typing on Discord at the moment. So DJ Devon 3 says the NRF 52840 has some of the best Bluetooth support, but it looks like the S3 is in development for it, I think. I'm not sure how well it works. It definitely could work, yeah. Because like the ESP32 has both the BLE and the classic Bluetooth, but I think the S3 is just going to be for the Bluetooth BLE, which is kind of the newer Bluetooth, and that's actually what this uses. So that could be a possible option, but this was actually designed for more of this form factor here, so it works really well. There is another option available in the Adafruit store, and there's like this little bot here, which could also take the CLUE, and it's actually really easy to insert it, but it has this sonar sensor on it, and you could actually remove that and just plug in whatever and be able to make use of I2C. That's an option if you're using like the microbit V2 without the STEMMA QT. And this has a couple little RGB LEDs, so I think it would be a different library for that. But this one is another little option. And let's see. Oh, Charles B says you have an extra copy of the digital I/O import. I have digital I/O and display I/O. I'm not seeing it. I mean, they're very similar and they're the same length of text here, but yeah, it's probably just display I/O is what you're seeing. Anyway, thank you for watching, and let me go ahead and swap this out here. Thanks for watching and joining me, and stay tuned for lots of other CircuitPython Day festivities. And I think coming up next in about 20 minutes is Liz doing a special CircuitPython themed show and tell, and that should be fun. Thanks.